Thank you very much. That was a very generous welcome. I'm delighted to be here. And at least today, this will be the best in-person talk that there's been in the series. So I'll just cling on to that possibility. Okay, so I've got quite a few slides, but because a lot of what I want to talk about is a case study, and so I've got some pictures which help you understand what's going on in the case, but I'll just, I seem to have a mouse in the middle there. But I just want to give a bit of the background to where this project comes from and why I'm talking about this, because as Simona indicated, a lot of my work has been, it's been case study based, but I started looking at these issues really from the point of view of activists and environmental organizations who were facing a problem of how do you deal with campaigning around issues where a critical question is who has control of the most authoritative scientific knowledge. So if you want to campaign about something, how do you criticize or in some way get round the establishment science? How do you generate alternative knowledge that legitimates the kind of conclusions you want to arrive at? How do you handle these questions around objectivity and politics? So that's kind of where I started from. But just recently, I've been invited to participate in a bigger project. And so this is really the first time I've had the opportunity to talk about this in person as well. So that's why I'm probably going to give you too many pictures of the case, or at least one of the cases, because that would jog my memory about the things I want to say. And also, I haven't quite worked out how to describe them, and the pictures probably do it better than me. So if I use this, does it show up on the, or do I do it on here?
I think it doesn't show up, I'm sorry.
Okay, right. There is a big initiative of our research councils. So our research councils are the bodies which give government money to university researchers. So they have pots of money that you can apply for just in a kind of free way with your own idea, but sometimes they also have a special initiative on something that they think needs investigating. And at the moment, there's a big interest in what they call work on the foundation industries. So in red ink at the top is this issue about the transforming foundation industries. So the research councils I'll tell you what a foundation industry is in a second, but the research councils are concerned about how do we have industry in a period where we're committed to net zero. And so that's why my talk is the thing that's highlighted at the bottom: decarbonisation, Brexit, and the foundation industries. And most of the work that I've done on this has been done in association with a research fellow. I think you'll see his back at one point in the slides. He's called Kyle. And he has a background in chemistry and in STS and has been invaluable in this process. Okay, so title for today, Decarbonisation, Brexit and the Foundation Industries, how to make stuff like aluminium, glass and steel in a net zero oriented nation. So the research councils, as I said, are concerned with these big industries. They've got a kind of, these are the slides that have been produced for the project as a whole. And in the middle of the screen, there are a bunch of pictures. These ones, which are intended to convey what they think of as the foundation industries. So they're the things from which other things are made. So it's glass, it's metal, it's bulk chemicals, it's metal, it's glass, it's cement, it's paper and board, and it's ceramics, okay? So these are the foundation industries because you need to make steel in order to make other things, or you need to make aluminium in order to make train bodies, and so on. So the question really for the UK and many other countries, which we'll get to later on, but of course this is a UK initiative, is how do you, what do you do about this in the context of your net zero commitments and also in the light of Brexit? So do you just say, well, those things are very polluting, we're not going to do those, and we'll let somebody else worry about the emissions that come from those, and we'll just import them for our industry and fabrication? Or do you essentially say, well, that's pretty risky and it's also environmentally a bit neglectful, so we should find ways of doing these things within the UK, and then how do we simultaneously do that and manage our net zero commitments? Okay, so just finally, by way of an introduction, within this project that we have, so there are 3 bits of funding about this Foundation Industries Challenge. We are we're a hub, except it's a kind of, it's not, you think of a hub as being in a place, but it's a distributed hub. So these are the universities that are involved in this. So some of them are working on different parts of the project, but these are all the partners that are involved in the hub, and University of Edinburgh is nice and close to the middle there, just because it's alphabetical order, I think. Okay, so let's go back to the foundation industries. As I've tried to explain, the foundation industries, this is a term which I think has circulated in engineering and engineering management terms for a while, but it's been really picked up by our research council, who are concerned about this problem because in the light of Brexit, which is beginning to look, more regrettable every day, but in the light of Brexit, we have 2 problems, well, probably 3 problems. One is that in the context of the European Union, although there was a lot of competition in steel and aluminium and glass and paper, at least we were operating in a large environment where the rules for competition between different national producers were pretty regulated within the context of the European Union. Now we're trying to find our own way after Brexit, and it isn't quite clear how firms should orientate themselves. I mean, so there was all this idea that we could become the sort of the Singapore of Europe or something of that sort, but nobody seems to really know how to do that. And the question is, well, what do you do with the foundation industries that we have? Because a lot of that wasn't set up on the expectation of Brexit. So our steel industry, for example, has very big problems. And there's a question about, well, how do we handle that in light of the opportunities and threats of Brexit? Of course, the firms also had a big problem recently, which the funders didn't quite anticipate, but has made the problem more severe, which is that they had problems with COVID. How do you operate a foundation industry if you're trying to have people working from home? And, it's very difficult because most of these things are very, depend on a lot of presential work. And of course, there have been problems with the labor market, so that a lot of these industries depended on bringing people from the eastern parts of the EU to work in many of these contexts. And so a lot of these businesses are now coping with a labor shortage that they hadn't quite anticipated. So we have the plight of the foundation industries, has these 3 problems that you've got to work out what to do about your foundation industry in the light of, how can you do this and head towards net zero? no emissions by 2050, or in Scotland by 2045. How do you think about this in relation to Brexit, and how do you cope with the fact that you didn't have the workers that you previously were hoping to have, either because of COVID or because of shortage of labour from other countries? Now, within our hub, we have 3 work streams that are supposed to look at different aspects of this challenge that the foundation industries are facing. So one of these is essentially to do with trying to identify best engineering and material science practices and seeing whether the firms can implement improvements that arise from the latest research. So this has a very engineering and material science kind of mindset to it. But for example, there's some actually rather interesting work going on there. So you may not have noticed, but one of the partners is the British Geological Survey, and they're going around trying to understand, compiling a kind of inventory, a list of the holdings of different mineral substances, because often in the past, things which are available in only small quantities haven't been very systematically compiled into the lists. And so they're going around again, trying to work out, well, if we have this cement quarry, what else is it that they're digging out, and what other uses could that be put to, so that they can think about sharing of resources between different foundation industries. So one is trying to work on sort of best practice. A second is really about mutual learning. So as we'll see in a few minutes, a lot of these industries need dryers, or they need furnaces, or they need ways of cooling. And although the steel manufacturers keep an eye on what other steel manufacturers are doing, they don't necessarily spend a lot of time talking to people from the ceramics or glass industry about these things. So there's this idea that there could be business to business learning across sectors. And so there are people trying to work on that aspect. And then the bit that we're mostly working on is the third thing, which generally, and social scientists will be familiar with this, this is often thought of within the context of this hub as non-technical barriers to transforming the foundation industries. So, so they think of transforming the foundation industries by using the latest research, by sharing knowledge, and then there's all that other stuff that's something to do with society and economics and stuff, and that's us. Okay, so the 3 work streams, 1 and 2 are fairly tightly characterized, and then number 3 is everything else. Okay, so where everything else? The social science issues, so as I said, we, as it were, the brief that has been offered to us is to think about non-technical barriers, which is actually an interesting challenge, because as we'll see when I talk about the couple of cases, there are some conspicuous non-technical barriers. And so it's interesting to think about, well, how do we bring the resources of social science and socio-environmental studies and so on to this question of the non-technical barriers. But of course, we also want to use this as an opportunity for a broader assessment of the political economy, what is going on. So very often the non-technical barriers framing of this assumes that, well, there is a good solution, but there are just obstacles to implementing that good solution, and that's the non-technical barrier. Whereas, as Simona's introduction indicated, well, we might want to reframe the whole question of the political economy of this as a different kind of non-technical barrier. And then the third thing that we've become interested in doing is trying to use social science techniques which are to do with, I mean, some of them are based on a kind of revised focus group or citizen participation models to co-imagine opportunities for the future of these industries. And I'll come back to that in the light of the cases. So those are the three things that I see us as being involved with. So the non-technical barriers, roughly as we're offered the problem, and then a broader assessment of the political economy, and then this issue of can we use a broader form of consultation for co-imagining future opportunities. Okay, so I said that I'm got a case with too many pictures, and so here we go. So the first case that I want to talk about is in a place in Scotland called Fort William. So Fort William is the obviously the English rather than the Gaelic name for it, because there was a fort there and it was in honor of William, Duke of someone or other at the time. So this is a town in the Highlands on the west coast of Scotland. And it now has the distinction of being the UK's only aluminium smelter. So to my surprise, I found there was an aluminium smelter in Hamburg, which itself has an interesting story about how it was financially resurrected by essentially a strategy of sourcing electricity in a more economical manner. But Britain had a number of aluminium plants. Most of these were associated with power stations because, I guess as many of you will know, but maybe some of you don't, aluminium is not like most other metals where essentially you have to heat up the ore with something that will take the oxygen away, and then you cool it down again and it turns into the metal. I mean, that's sort of what happens with iron and steel. With aluminium, you have to zap it with lots of electricity, and it's only in the presence of the electricity that you'll have the similar operation that will produce the liquid aluminium. So you need, generally you need loads and loads of electricity. And so by and large, our aluminium smelters have been placed in locations where there is electricity. So that meant that in the northeast of England, where we used to have very big coal mines, there was one aluminium smelter, which essentially had its own coal mine. They would bring the coal up from under the ground, burn it, make electricity, do the smelting. When we got out of coal and when the politics of coal made it advisable to get out of coal, that aluminium plant just closed because the electricity was gone. We had one in Wales that was close to a nuclear power station, but they ran into problems with pricing and also effectively the nuclear power station getting a better offer for its electricity than from the aluminium smelter. So that one closed down. There were some others that were coal powered, where the coal was brought in by train, and they've gone too. So we're left with this aluminium smelter. And what allows this aluminium smelter to continue to operate is that it has its own hydroelectric station. So essentially, I mean, I don't know if many people from Germany seem to like Scotland. That's my impression. So many people will know that the highest and most famous mountain in Scotland is called Ben Nevis. So Fort William is right next to Ben Nevis, and the power station really is fed by water that runs down from the side of Ben Nevis, as we'll see in a second. Now, this is actually quite an old hydroelectric station. So one of the first ever, it's coming up to its 100th birthday. So aluminium was the kind of celebrity metal of the latter half of the 19th century and the start of the 20th century. So it was what allowed you to build airships and early airplanes. It had all these kind of decorative and architectural uses. And so it was important for Britain to have access to its own supplies of aluminium. So this hydroelectric station was built purposely in order to feed this hydroelectric station from the start. It was expanded and things changed, but essentially that relationship has been there for the start. And the final thing about this is that because the water that feeds this electric system is rather widely distributed, the aluminium plant and the hydroelectric power station have a very big estate. So they have, so they own most of the land around Ben Nevis, but not Ben Nevis itself, which is a kind of national monument. They have other bits of land. There's a map soon, so you'll see that. So it means that you can buy venison, deer meat from the estate of the hydroelectric power station because they need to maintain everything and they have a lot of deer, so they have shooting of the deer and deer management and so on. So in the case of Fort William, you've got an aluminium smelter tied to and completely dependent on the hydroelectric power station. And then in order to maintain that, you've got an estate. Okay, so I'm sure pretty much everybody knows about Scotland. So this is a map of Scotland, and essentially Scotland has sort of three chunks of mountains. So in the middle bit, Edinburgh and Glasgow, the vast majority of people live in here. These southern uplands, they're not particularly tall, but they mark the old kind of boundary with England. And then north from Edinburgh and Glasgow, you have what are the Highlands, where the Queen's residence used to be and so on. So this is the kind of area you think of as Scottish Highlands. Ben Nevis there is marked. Fort William is on this loch, this sort of fjord that runs in from the southwest up there. And then north of this line, which is where the Loch Ness Monster and so on live, this line up here, that bit is a different geological age to the rest. And geologists would say, actually that properly belongs with Nova Scotia. There's a bit of Canada that got left behind by accident. And so the terrain there looks rather different. So Fort William is kind of on the edge of the Highlands because it's close to that fault line that runs up. And this map also contains, not very conspicuously, but the names of a bunch of places. So people will, I think, know Edinburgh and Glasgow, but then you have Dundee, which is on the coast here, Aberdeen, which is one of the centres of the oil industry up there on the northeast. And then in the middle at the top is Inverness, which is the kind of administrative centre for the Highlands. So the Highland Council is there. So the council is a administrative region. So Edinburgh has a council, and then there's the Highlands Council, which covers, a huge bit of the country. But that is headquartered in Inverness, and they feature later in the story. Okay, so what does this roughly look like? So this is a photo that I took in March of this year. So this is looking back in towards Fort William from the top of that fjord that I talked about. The hill that you can see just in the background, sort of behind the Blunt Hill here, the one at the back is Ben Nevis, and the power station is over here. You probably can't see it, but you will in a second, because over here are the turbines down, are the pipes down which the water flows into the turbine, which in English are called pen stocks. I don't know why. I mean, that comes from the theory of how to build a dam in the 15th century or something, but they still use the word. They're called pen stocks. I only learned this because people were talking about pen stocks and I didn't realize that's what they were called. So this is the kind of context for it. So here we have a map of Fort William. I tried to stay in the picture. So Fort William, apart from being the site for this works, is also a major tourist site. So a lot of people who want to go on holiday to the Highlands go to Fort William. And when we speak with people locally, they say, you know, it's a strange kind of place because for about 6 or 8 months of the year, it's very, very quiet. And then for the summer months into you know, sort of May to September or something, it's completely full of traffic. You know, so it can sometimes take them, you know, an hour to get across town in a car, if they're foolish enough to do that, because there are just so many people trying to get in there for touristic reasons. So this is Fort William. The plant we're going to talk about is here, just outside. It has its own rail connection there. And then the areas around, so this is the sea loch that comes in and bends around and goes to the west where it stops. So the areas around here, there used to be a paper mill, and there still is a sawmill, and then you've got various housing areas. So Inverlochy here, the place that has the Gaelic name that is pronounced cool. Here, so I can't jump that far, but I'm not sure if this one, but this area here is a housing essentially for people who used to work in the paper mill. And then there's also in Corpac, there's a jetty and harbour, which used to be used for getting the paper and still is used for getting some of the timber products out. And this is going back to my photo from before, blown up in a way that I hope you can now see over here. So this is the pipes that take the water, which you'll see more about in a second, down into the factory. So the factory is down here. This looks kind of dramatic, but that's just, they're redoing the beach, and because of rising water levels, they're having to protect the houses by putting in stones to prevent erosion here. So they've stripped back the beach. So it's got nothing to do with the plant. This is more of a general climate change issue. And here we have an aerial image of the plant. So it's difficult to read this. I mean, since I know it fairly well, I can sort of see it, but it isn't the 3 dimensions of this, I think, aren't terribly clear. But essentially, from the top left, you're coming downhill very steeply. So this brings the water down into here. This is the turbine hall. This is the area where the electrolysis of the aluminium takes place. And this is where they do the casting and storage of stuff. The rail line comes in here, bringing in the mineral, the alumina, which is used in the process. And then finally, in relation to the estate, so the plant was bought 5 years ago by a complicated set of arrangements, but involving the Indian investors, the Gupta family, and they have split the ownership of the factory from the ownership of the estate, although they still both belong to the same family. And the estate is now known as the Jahama Highland Estate. Here I just want to show you that in order to be able to regulate the access to the water, they need ownership of these, and they have to environmentally maintain these two large areas. So the distance from here to there is about 20 or 25 kilometers. So this is, roughly a 20-kilometer square. So the water that feeds the plant comes from these very distant lochs. So this loch is artificially created and used to feed an aluminium plant, which is even older and is now no longer in existence, in Kinloch Leven. But the reservoir still feeds a power station there. For the current aluminium plant, you've got water that comes both from the sort of oblong area, rectangular area in the top, which is Loch Spey, which has been dammed, then feeds into the Spey Reservoir, goes down the River Lagan into then this loch here, which is dammed, and then the water from there passes in a tunnel and meets with the water in this humanly constructed loch as well, Loch Teague, and then the water flows out of there through tunnels along, they tunneled under all the way until the water pops out in those pipes that flow down into the back of the factory. So I've never managed to get into the tunnels, but these are concrete tunnels that are apparently between 4.5 and 5 meters in diameter to take all of the water from these 5 sources into Fort William. They also collect water from various streams and so on as they pass. So there are places where, the tunnel is underneath and a watercourse flows over the top, and there's a kind of grate where the water can fall into the tunnel so that it's perpetually topped up. Okay, so this means that they, you can see, firstly, that this area just around Ben Nevis is exempt from, so it's not part of the estate, but they own this very large estate. They have to spend a lot of money maintaining the dams and the reservoirs and the pipes, but also it means they have a lot of natural environment to manage also. Okay, then just to give a final sense of how this feels. So when just now I talked about the this aerial view, so you have the pipes, the penstocks coming down from the top left, and they run through and into this turbine hall, which uses the water to power turbines to charge electricity. The water is then the spent water exits here and goes down the side. So I'm going to show you a picture of this turbine hall, and then this is the smelting zone, the larger building on the top. So, so the turbine hall is, this looks kind of tranquil, but it's incredibly noisy in there. It is not well designed from a workforce point of view, but this is the building that is nearly 100 years old. The turbines themselves, the blue things, have been replaced, but it's the original hall. And when everything's running, it's essentially impossible unless you have a microphone in your protective headgear. You can't really talk to anybody else. So I've been talking to people in there, but in fact, I have no idea what they said. And it's very difficult to find anywhere that you can be understood. And then this is, so that's my colleague's back. And this is the place in which the aluminium smelting occurs. So essentially, as I've said, to produce aluminium, what you have to do is to pass electricity through the aluminium oxide, and that's done in these cells. They are the grey cabins here. This big fat thing here is effectively the wire that supplies the electricity to the cell, and it is at very low voltage. So although it's absorbing an enormous amount of electricity, it's actually reasonably safe. People can work on the equipment even while it's running, although it gets fantastically hot and of course is fantastically noisy again. And a persistent problem is how to keep these things cool enough, and I'll come on to that in the story in a second. So this is a vast hall, and essentially it has a run of these cells in which the electrical process, the electrolysis takes place, and then this is in one of them. Over here, there's a parallel building that has the same thing going on. And then finally, at the end, they make aluminium. So it is taken, I'm taking up quite a bit of time, so I won't go into this very much, but it's taken from the, so the electrolysis pits produce the aluminium. The aluminium is produced within those cells and sits there until it's kind of siphoned off. So they have this thing that looks like a sort of mechanical elephant with a big nose that goes in and sucks the aluminium out. And then it's carried over while still liquid and then cast into these lumps. And so these are, I mean, they're this wide, so you can see that they're 7 or 8 meters long. And this is the finished, so this is 3 of them stacked on top of each other. Those are the finished product, although they can make other shapes. But essentially, these are cast into this shape because they have, there's like a metal pan into which the aluminium is poured, and then the pan descends into the floor the height of the bar. So this is, this thing at the bottom is, as it were, the shape of the pan, and then the pan descends as the metal is poured in and gradually solidifies. And so they make aluminium, keep it liquid until they've got enough to produce one of these bars. They produce the bar, then they start again. And that's essentially the process. Now, what I want to talk about, and I've got, what, 15 minutes or so? Yeah. So I want to talk about what's going on with this. So firstly, in all stages of this process, you've got, and everybody can sort of see, you've got heat being lost. So in these cells, so they take essentially all of the production from this hydroelectric power station and they turn it into electricity, which feeds these cells. The cells get very warm. They don't want them to get too hot. So this shed is built, raised off the ground, and the cells, I mean, this looks like this is a very strong floor because big tractors can drive along it, but this is up in the air, supported on cement blocks all the way along. And these cells stick through the floor so that they can be cooled just by air passing, okay? So they need to keep them cooled. They do it just by exposing them to the air. Similarly, when it comes to the production of the blocks have to be cooled in order to solidify, but they don't recirculate the heat from that cooling. They essentially depend on the air and on spraying them with water to cool them down. They need to cool reasonably gradually. So that produces, I mean, fortunately, Scotland has an abundance of water, so they don't really have too much difficulty with finding the water to do this, but then the water cools them down, itself is heated and is released to the environment. So we have this situation where everybody can sort of see that it's sort of crazy that you've got a power station that you're using to produce electricity, you're using the electricity to make things hot, and then you're just letting them cool down. But nobody is really doing anything about that. So that was kind of the first puzzle to us. You know, so how is it possible that there can't be, either technically or in a market sense, someone who wants to recover all of that heat? So partly, I think there's sort of three reasons for this. One is that the design, as I said, I mean, this thing was built 100 years ago when the overwhelming consideration was Britain needs aluminium, needs to have its own way of producing aluminium and needs some control over aluminium production. So we're going to do this thing. In fact, there's a whole history about these dams and the flooding of the valleys and so on, which we can talk about later on, maybe, if people are interested in that. But essentially, a lot of this design was built in from the start. And although people are up to changing, you know, they say, well, yes, we have to replace these cells, but the cells are not replaced frequently. You know, they're replaced maybe every 20 years or so. So it's difficult, you know, there's a kind of design logic, there's a kind of path dependency that's locked into this. Secondly, there's a concern about exactly who might be in the market for that heat, so that the Scottish government is quite keen on using heat for domestic heating and for heating towns and cities, but there's a problem that they don't want to get in a situation where they're dependent on this factory for the heat. So this is kind of almost like a game theory kind of thing. But if you end up in a situation in which your town is dependent on the heat from this factory, but you want to have a kind of free market approach to that factory, you know, so that, you know, somebody may find a better way of manufacturing aluminium, or the company may decide to sell its aluminium production or something of that sort. And of course, the government doesn't want to nationalize that. They don't want to end up in the situation where suddenly the company is able to say, well, if you don't help us, you're going to have a lot of cold citizens because they're dependent on the heat from the factory. So the government is understandably, I mean, the civil service advisors are understandably very concerned not to get into a situation where, even though there's lots of heat from the factory, the town becomes dependent on this heat. So where do we go with this? So one of the things that is very striking about this and other cases is what I've called here, in a jokey sort of way, hotness. So I mean, obviously hotness in everyday conversation isn't really used to talk about industrial products and so on, but I'm trying to make a distinction between heat and hotness. There's probably a better physics term for that. But by hotness, I mean, you would think that the sustainable way to do lots of processes would be to do them at the lowest temperature possible, so you don't have to waste heat on producing them. But of course, in many of the foundation industries, you end up with a process that, so far as we know, is inevitably hot. So if you're going to make aluminium, you're going to end up, if you're going to electrolyze stuff to make aluminium, you're going to end up with aluminium at 900 degrees. So you're going to end up with some hot stuff, pretty much, whether you want it or not, whether that's heated by electricity or however you've done it, you're going to end up with this heat. And that would be true even if you tried to move your aluminium production away from sort of virgin aluminium production to recycled. If you're going to, have lots of drinks cans and you're going to melt them down, well, you've still got to get it up to the melting point of aluminium. So in a lot of these foundation industries, one of the recurring things is they end up with processes that are hot, often in places that are remote, because they were chosen in order to be remote, so that people were, in this case, because you've got the locks and so on that can provide the electricity. In other cases, because they wanted them to be remote from centers of population for reasons of noise and disturbance and so on. So you have, with the foundation industries, this problem of, even if you try to decarbonize them, and of course, this in some sense looks like pretty good decarbonized aluminium because the electricity is from hydroelectric sources, although carbon is actually used in the process in a way we can talk about later. But you end up, so even if you decarbonize, you end up with this hotness. And this is, there seems not to be a strategy for benefiting in general terms from this hotness. There's very little in the way of investment in heat recovery. In some cases, they're lucky, they've got lots of water, they can just dump the heat into the environment around them. There are some cases in which we've heard about where people have water that comes out of the cooling process that is still too hot to release into the environment, and they have to spend energy on cooling the water in order to be able to discharge it. So you get these big problems around hotness. Secondly, you have this issue of waste heat. So in Scotland and elsewhere, people are kind of interested in identifying waste heat, where heat is inevitably produced. So like sewage plants, for example, produce a lot of heat just because of the bacterial and other reactions that take place there. So what can you do with that heat? And I think one of the very interesting issues that comes out of this is this whole terminology of waste heat. Presumably, once you have really got to net zero, you're not going to have a concept of waste heat anymore, because heat will be so valuable that I doubt that there'll be much waste heat around. And of course, all the time that you create a market for waste heat, you also create an incentive to people to keep producing the waste heat. Now, sewage treatment works, maybe that's inescapable. But in lots of other contexts, you could think, well, trying to benefit from waste heat provides a kind of negative incentive because you don't really want to have waste heat at all. Third thing I want to talk about very briefly is to do with heat networks. So I've mentioned that the Scottish government has even more ambitious targets for net zero than the UK government as a whole. So one of the political points about Scotland is that often Scotland, which has independence in several policy areas, but not in all, often Scotland wants to be seen to do things differently and better. So they've set a more rapid decarbonisation target. They want to have 2045 rather than 2050. But of course, just wanting it is not always terribly easy. So you've got a lot of people who are working on this who are really struggling with thinking how they're going to deliver that. And Scotland, of course, is north of England, and so is on average colder. And so there's a lot of heating needed in Scottish cities, or in Scottish homes, most of which are in Scottish cities. Now, the government is very interested in setting up heat networks. That's not something that Scotland or England has really done very much in the past, but there are lots of models from continental Europe that are available for us to copy. But in the Scottish case, they decided to start with the cities that I mentioned early on the map. So Edinburgh and Glasgow and Aberdeen and Dundee and Stirling and Inverness and Perth. I knew there was another one. So those are officially the 7 cities of Scotland. And so they're going to start with heat networks in the cities. So that means that somewhere like this power station is not going to have a heat network constructed anywhere near it for decades and decades. So again, there's that question of, well, you're going to have this residual hotness. It's difficult to think what they're going to do with it. How do you think about decarbonisation in that context? So could you sell heat? I mean, so if you're going to have this hot thing that you've got to find a way of cooling down, it's probably going to cost you more to cool it and recover the heat than it is to dump it into the environment at the moment. What could you do with that? So maybe you could have, I don't know, greenhouses growing tomatoes or something. That's another Brexit topic, right? Where Spanish and Netherlands tomatoes, Belgian tomatoes, we could replace those with Scottish tomatoes. So who is putting those kind of deals together? And as far as we've been able to see, talking to people in the industrial development boards and so on, nobody is thinking about this heat as something that is a resource to build into these kind of models. So whenever we've tried to bring this concept up, you know, people said, no, we don't really do that. So you could sell heat into sort of market gardening, or you could sell business premises that have access to steam or something of that sort. But that doesn't seem to be on the cards so far. Then funding in the future, well, whenever we speak to people in these plants and in other ones that I won't be able to go into now, the engineers are often very conscious of these topics, but they want to know how we can unlock the move to the next stage. I mean, so if there was a big carbon tax that changed, you know, if they could get credits, for example, because of their hydroelectric production and so on, and then they could use some of those credits in order to invest in heat acquisition equipment and then sell that on so that they would get a kind of double carbon benefit. They could sort of imagine doing that, or if there was a straightforward grant or something. But how do you fund that transition? The company doesn't see a way of generating enough profit out of reusing the heat for them to want to fund it. Where else do we go? And of course, whenever we've tried to speak to local politicians and people from the Highland Council, which I mentioned, based in Inverness, you know, again, there's some interest, but there's always this question of, well, we would love to do that, but we don't have the funds for these kinds of things. Where could we ever get that kind of money? heat and the environment. So one of the things that I kept mentioning was that they have this estate. And of course, part of having the estate is that they're subject to inspection by the SEPA, the Scottish Environmental Protection Agency, for how they maintain the estate. And then also they're responsible for discharges into the loch and so on, because all the water that comes out of the turbine has to go somewhere. And of course, there's an issue here about how easy it is for the environmental impact of this, you know, an aluminium plant or a plant of this sort, to be reduced to its carbon impact. And one of the things that the environmental staff within the factory, you know, they're very conscious of having to maintain good relations with the Environment Protection Agency inspectors who come round. So in this case, there is quite a tight connection between environmental protection and heat. But in other cases we've seen, you know, the connection is very much climate, emissions, heat, but not really thinking about the broader environmental impact. And then this leads me on to the final thing that we're trying to do. We haven't managed to get it going in this case. We've tried and had some success in a couple of other cases, is to think about, well, how can you use sort of broader participation and facilitation techniques to get some of these alternative futures thought about and brought forward into the planning of these kind of agencies. So in the case of Fort William, you've got essentially people there's quite a strong local environment group who are doing things like trying to set up a community electricity generation scheme in another river, who've got lots of ideas. They have a bike scheme to overcome those traffic jams I was talking about, and lots of other things. But there isn't yet a forum in which they are able to talk about the heat and the possible environmental benefits of that heat with local politicians, representatives from the company, officers from the local authority, and so on. So in other cases, we've tried to use techniques to get people to think about, you know, well, you're doing things this way, but are there different ways that you could configure the plant, or different kind of relationships you could build with your neighbors, so that some of these problems of a market for the heat and so on become resolved through a kind of dialogue process with potential partners. So one of the interesting things that's going on at this aluminium plant is that they are keen to expand their production, because, you know, everything that depends on primary production is often working at very close to survivability. So they're always looking for more things that they can do. And when they were telling us their plans for, you know, what they might expand into, we were saying, well, you know, so how would you power those new things? And we were expecting them to say, oh yes, we'll capture some of the heat from this process and we'll use it to power the new ideas that we have. But that wasn't there at all, because they said, you know, they have various requirements that they have to address in terms of emissions, noise, transport, other planning considerations, conservation kind of issues, and they have to meet all those criteria. The issue of internalizing heat isn't even on the list of criteria that they have to address. So of course, it's not high up in their planning. And in fact, you know, we were just completely surprised by the fact that they've got, you know, essentially they've got a whole power station's worth of heat, which they're dumping into the environment. And then they're going to have a different power source for their new initiatives. And you think, you know, why isn't that a mandatory requirement under the planning system? But it isn't. So that could be a co-imagined future. Okay, so I think I'll leave it there. This is really about our first attempts to see what's interesting from a social science perspective about some of these foundation industry things. Sorry about too many pictures, but I hope you got a sense of what this facility is like and for some of the problems that it throws up for the environment and for environmental social scientists. Thank you very much indeed.